Well, I'm sorry that I can't be there today, but you get the next best thing. A live, well not live, but a video. So let's begin, and we're going to do one problem from each section to get you started. So first thing we see, we have to factor each expression. So we know the word factor means to write as a product. So you can see each of these problems here, these are all in standard form, and we need to rewrite them in factored form. And do you remember the first three steps in factoring, what we look for? So remember, step number one is we're going to look to see if there's a greatest common factor. Step two, we're going to ask ourselves, is this a difference of two squares? Because if it is, then we can write it as a product of conjugates. And the third thing we're going to look at then is, if it's neither one or two, is it a trinomial? And we know that a trinomial can be factored in a product of two binomials. Okay, so let's get started. How about if we do problem 3 together? That looks like one that might be challenging and sufficient for our time here. So 4n squared plus 10n minus 6. First step is look to see if there is a greatest common factor. Whoops, just knocked over my cup. Now we notice that there's a 2 in common, so we're going to So here we have a 2 that's in common, so I'm going to factor out, whoops, I need to be in pen mode. Okay, so we're going to, oh my word. There we go, let's try this again. So we're going to factor out the 2. So 2 times 2n squared is 4n, 2 times 5n is 10n, and 2 times negative 3 is negative 6. So now we look inside the expression, and it's not a binomial, it's not a difference of two squares, but it's a trinomial. So I'm going to ask myself, what will multiply to make 2n squared? And that would be a 2n and an n. And then what are the factors of negative 3? So we can either use 1 and negative 3 or negative 3 and 1. But we have to be careful on their placement because the leading coefficient is 2. So if I place the 3 here, we notice that the product of the outside terms is 6n. And the 1 here, that would be a 1n. So we see here 6n minus 1n would give us 5n, which is exactly what we want. So the factored form would be 2 times the quantity 2n minus 1 times the quantity n plus 3. Now let's do a problem from the second section where we have to solve using the zero product property. And so with the zero product property, just like its name says, the first thing we will do is we'll set the equation equal to 0. Okay, so step 1, set the equation equal to 0. Step 2 is write the expression in terms of a product. So 0 product, and then we're going to use the property which says that if you have two things that multiply to equal 0, then at least one of them would be equal, and we get our two solutions. So let's take a look at, let's do 7 together. So we notice it's a quadratic equation, so there will be two solutions, and we're going to use a zero product property. So first thing I'm going to do is I'm going to subtract 16m from both sides so that the equation will be equal to 0. Now I write it in descending order, m squared minus 16m minus 36 is equal to 0. Now the second step is we have to write it as a product. So I need to factor this trinomial. There is no greatest common factor, so I'm going to write it as a product of two binomials. Well, we know m times m is m squared, but what multiplies to negative 36 and adds to a negative 16? Let's see. Oh, 2 and 18. Did that work? Yes. And the negative 16 is larger, so I would need m minus 18 and m plus 2. So that'd be a negative 18m plus 2m is negative 16. Now we're going to find our two solutions. So if m minus 18 equals 0, we know that one of the solutions will be 18. And if m plus 2 equals 0, we know that the other solution would be negative 2. Great. Now let's go ahead and do one problem from the back side. Okay, so in the back side, the directions say we have to rewrite each quadratic equation so that it's in perfect square form. Quadratic, now perfect square form means we're going to have some quantity squared equal to a constant. That's called perfect square form. And then we'll solve using the square root property. So let's pick one. Let's see. How about if I do 12? So first thing we want to do is we want to rewrite it so it's in perfect square form. So in other words, I need to get the x plus 9 squared. I need to isolate that. So first thing I'm going to do is I'm going to add 4 to both sides. So now I have 6 times the quantity, x plus 9 squared is equal to 36. Now I'm going to divide by 6, so I have x plus 9 squared equals 6. Now notice we have it in perfect square, and it's a perfect square equal to a positive number, right? We have positive 6. So that means we know that there will be 2 solutions. So when I take the square root, we're going to get plus or minus. So square root of both sides, square root of the left side, square root of the right side, we're going to have x plus 9 is equal to the 2 solutions plus or minus, and radical 6 cannot be simplified. Now we're almost done. We just need to get x by itself, so I'll subtract 9 from both sides. So x equals negative 9 plus or minus the square root of 6. Now the solution is an irrational number, but that's okay. You know, some solutions are irrational. So there we go. That is the solution to 12. Now you're going to do 11, 13, and 14. And last of all, the last problem say you get to choose which method you'd like, zero product property or perfect square form. Now some problems might not be able to be factored. If you cannot factor it, then you cannot use the zero product property. And some quadratic equations may not be able to be written as a perfect square, so you'll have to use a zero product property. So if one method doesn't work, then you got to try the other. Let's see, which one should I use? Or which one should I solve, let's say. How about if I solve, I don't know, 20 maybe is the toughest. Now I look at 4x squared plus 10x equals 24. Now if I tried to write it as a perfect square, I notice I'd need to get the left side here has to be a perfect square, right? It has to be something squared equals 24. But is that a perfect square, 4x squared plus 10x? I mean, I know they have a 2x in common, so it'd be 2x times 2x plus 5, but that's not a perfect square. So the left side cannot be written as a perfect square as it is. So as a result then, what happens is I'm going to have to use a zero product property. So I'll just delete that work right there and we'll start again. So zero product property tells me to set the whole thing equal to 0. So I'm going to subtract 24 from both sides. 4x squared plus 10x minus 24 is equal to 0. So I set it equal to 0. Now I'm going to factor it. But I notice that there's a 4 in common, so we always take out, no, not a 4, I'm sorry. There's a 2 in common, right? 2. Oh dear, I want to just erase that 4, but it won't let me. So you know what, folks, I'm going to have to kind of do this rough. I'm just going to have to scratch out the 4 and put a 2. So we're going to factor out a 2, so I'll get 2 times the quantity, 2x squared, plus 5x minus 12 equals 0. So now we've got a trinomial, so we're going to have to factor this trinomial here. So it's going to be 2x and x. Now what factors of 12 can I use? But I have to place them in respect to the 2x and the x to add up to a 5. I like 3 and 4 because they're kind of close to each other. 4, ooh, that'll work because watch. If I put 4 here and 3 here, notice I get 8x and a 3x. Will 8x and a 3x make a 5? Sure it will. If this is plus 8x minus 3x. Yahoo! So now I've factored it. Now the product property says that if you're multiplying 3 things together and it equals 0, then at least one or all of them are 0. So we know 2 cannot equal 0, but could 2x, well, I'm running out of room here, 2x minus 3 equal 0? Yes, it could. And could x plus 4 equal 0? Yes, it could. So my 2 solutions would be x equals negative 4. And on this side, if I add 3, divide by 2, I get x equals 3/2. So those are the 2 answers. Now you work on the remaining problems. You can work with your partner and then finish whatever you have left over for homework.